Very good afternoon and welcome to this live session in this reliability-based structural design. So let me quickly brief you what we have covered till date. Probably you can see on your screen the complete list of lectures that we have uploaded. So as of now, we have gone through 8 modules. We started from the first module on theory of probability, covering the basic models that we need for structural reliability analysis. And then with that background, we first tried to solve a reliability problem using what we call mean value first order second moment method. There primarily we used algebra of variance that comes directly from the statistical analysis of the data. Now with that, we tried to solve and bring in the concept of reliability in our structural design. Now, the main reason is when we deal with actual structures, I've already explained, and all of you have gone through the course, that we cannot avoid uncertainty. It is always there. And therefore, when we design, we have to deal with that uncertainty in our design process. Now, the question is, when we design a structure, particularly in civil engineering, our structures, for example, when we design a bridge, we have only one sample of that is designed. We do not have multiple bridges of same drawing, same design. For example, in mechanical engineering, they produce products and then in a production line, they have same articles again and again coming. So the way they handle quality control in their entire production line and the design process is somewhat different than what we have here in our civil engineering. Here we have only one design, and there we need to incorporate all the possible uncertainties that we can anticipate a structure is going to encounter in its entire design life. That's the reason we first started from the data analysis and developed a model how we can incorporate the statistical information in our design process, which is primarily deterministic. Because the codal provisions that you see and whatever knowledge you gather from your undergraduate, that's primarily using deterministic variance. Now, obviously, this mean value first order second moment method, when you use using statistical information mainly up to second moment, it has its own limitations. I should not say drawback, but limitations. Because this statistical analysis is not meant for structural design, it's purely for data analysis. And from that point onward, when we move towards a more robust definition of structural reliability, and then we use Haushofer-Linde index. So a design process which primarily is based on factor of safety is now in a completely different non-dimensional number we call reliability index. So that problem, again, it's a optimization problem. And then in that optimization process, we basically consider again some random variables. And of course, as we progress in this course, we solve different types of problems that we encounter when we solve this optimization problem. For example, we started with uncorrelated normal, and then finally we ended up with correlated non-normals. And once we have this correlated non-normal, one of the interesting models that we discussed is how to construct multivariate PDF. And for that, again, different options are there. And we discussed 3 different options: Morgenstern, NATF, and Rosenblatt. All of them are extremely important and very useful. Particularly NATF is extremely useful for different analysis that very often we carry out in reliability-based design and uncertainty quantification. Then it was followed by some corrections on first order reliability method proposed by Brighton primarily. That deals with the correction based on the curvature at the design point. We have seen that if the curvature is really prominent, then its effect is also reflected on the overall probability of failure. And then finally, once we discuss all this gradient-based reliability model, obviously the question comes in your mind how we can verify this result. Is there at all any way? And in fact, not only that, there are some cases where we cannot write the limit state equation in closed form. Now, if we cannot write the limit state equation in closed form, obviously there is no chance of writing the derivative. There are, of course, numerical ways to do the estimation of gradient. The moment you employ a numerical method, obviously it has its own limitations. So if we deal with the limit state where there is no chance of having it in a closed form, obviously we cannot estimate the gradients very precisely, and which is actually the basis of reliability analysis. Now, in these two scenarios where if we cannot write the limit state in explicit form, or in case of even explicit form, if we get some results either from first order method or second order method, then how can we verify these results? For that, we have simulation-based reliability analysis. And there we discussed Monte Carlo simulations and variance reduction technique. Now, Monte Carlo simulation particularly, it's a very versatile technique. And in fact, you can simulate any uncertain environment using this. Of course, nothing comes free. The moment you have a very complex system with multiple number of random variables, then obviously this Monte Carlo simulation is itself very challenging, and sometimes its computational cost is so high that you cannot even employ this technique. So we have to go for even more efficient techniques. And variance reduction technique is one of them. And there I demonstrated how you can actually efficiently go for a simulation technique where just by choosing an importance sampling density function, where from we collect samples, and thereby we can improve the performance of simulation-based reliability analysis. Of course, the list is not exhaustive. There are many other methods. In fact, in the last module, we will also show you some other techniques, because if you wish to continue on this subject further, then you should have a fair idea what are other methods and what are the latest techniques, and how we can actually extend this for further applications. So that we'll discuss in the last. As of now, opinion, how we can reach you better. Yeah, I see Muhammad and Sisi, both of you are there. I hope I'm audible to both of you. Anybody else? Any questions, any doubt, any comments? Please share with us. Yes, Sisi. What is the question? Oh, it's there in the chat. Just 1 minute. Yes. So while solving first order reliability problem using MATLAB, I showed you different problems, and there one of the problem was to solve actual finite element model, because in design very often you use softwares, right? There are different softwares available in the market. For example, STAD, SAP 2000, and many more. Abacus. ANSYS is primarily used, very powerful software. We selected ANSYS simply because it gives you option for different finite element analysis. In fact, it has also a very strong module for fluid and its analysis and fluid structure interaction. So that's the reason we thought to combine ANSYS. Regarding ANSYS learning, of course, there are a lot of online research resources available. Sorry, so you can go through them, because when actually I started learning ANSYS from APDL long back, and today where ANSYS stands in Workbench, they have really large number of options available. Their online help is very good, so you can go through them. A lot of videos are available. You can go through them, and then you can try yourself. End of the day, if you have any trouble during this implementation of ANSYS with MATLAB for first order reliability analysis, we are always there. If you have any trouble, do let us know, and then definitely we'll try to help you out. As for the learning of finite element analysis, definitely, you go through those videos, online materials. So yeah, I hope that will cover your basic doubts. In fact, those materials cover basic and then intermediate and advanced level modeling and analysis. So if you go through those materials, I'm sure you'll be able to learn ANSYS, particularly Workbench, because in Workbench now they have really a lot of different options. And the way we combine first order reliability method, the way I showed you, it's exactly same whether you use APDL or Workbench. End of the day, you have to get that .inp file, and then using that .inp file, then you can actually do the reliability analysis. So any problem you solve in finite element, that you can combine with the reliability. In fact, in ANSYS, most likely they have a optimization toolbox also, if I'm not wrong. So there also you can go for some level of optimization in structural analysis, if I'm not wrong. That also you can combine with our model, the way we solve it. So I hope that clears your doubt. If you have anything more, you can please ask. Oh, yes. As I mentioned just a few minutes back, that in the simulation, we have just covered two different techniques. One is MCS, another is variance reduction technique. And that time I mentioned that in the last module, in the 12th module, we'll cover some more topic. In fact, I wish to discuss some more techniques how to solve the first order reliability problem. So again, during that week, we will cover this subset simulation simply because this is a 12-week course, 30 hours lectures. Normally in our regular curriculum, we have 45 lectures. So there we go little bit further. But here, of course, subset simulation I will cover. This is a really powerful technique. And using subset simulation, you can solve reliability analysis. You can go for optimization also, particularly reliability-based design optimization. These I will show you in the last module. Yes, it is very much there. Thanks for highlighting this, but it is very much there in our agenda. Yes, again, reliability-based design optimization, that's the topic we will highlight in the last module. And using subset simulation, also the materials that we'll share, you can go for reliability-based design optimization or sometimes robust design optimization also. So that we'll cover in the last module. In fact, topology optimization is one of the major problem that encountered in the industry and where we go for reliability-based optimization. That also you can extend using the models that we have developed in our course. There are a lot of research materials available, a lot of journal papers and online resources available for that. In this course, because we have a strict time limit, we cannot cover all of them. But just to mention that, yes, you can also go for design optimization using uncertainty within your design framework. And there, not only design optimization, you can also go for topology optimizations. So those topic we will highlight at the end, so that those who are interested to take it further in their academic endeavor, that they can. We'll share those resources at the end of this. Yes, as for your MATLAB applications, we are thinking to share some of the codes that we have developed and show you how we can implement, say, for example, importance sampling in MATLAB. That code also we are going to share with you shortly. So yes, it will be there. But I will always suggest you during this period also, if you can give it a try. And then if you face any trouble, then do let us know, then we can help you out. That will be far more interactive and encouraging for both of us. So by now, for those who are new to this subject, we have already shown you how to develop the MATLAB code. And of course, this exercise will continue till the end. So I will strongly encourage all of you, just give it a try. Let us see. In fact, all the examples I have shown you step by step, all these different parameters are discussed in detail. So if you can give it a try, that will be more fruitful for you. But at the end, definitely, we are planning to share all these codes, whatever resources we have, that anyway we are going to share. Any more questions? Anybody there? Here, actually, I wish to share one comments with you, because during problem solving in assignments, some of you have raised a lot of numerical questions. Actually, this first order reliability problem, you have seen that it is an iterative procedure. Whenever we have an optimization that we solve numerically, we start with an initial guess, and then as we progress through the iteration, we ultimately converge to the global minima or maxima, whichever problem we solve. Now, in that process, it totally depends on the way you actually formulate your problem. So it actually depends on the value that you use, even up to which decimal point you use your answer. That all matters. Ultimately, you'll reach the same optimal minima or maxima. But within the iterative procedure, you may have different values. So don't get confused. So long your mathematical model and your initial and final calculations following all these procedures are correct, the values are okay. Because in this assignment, we have a very limited scope to give you the problem. And sometimes also we use a lot of techniques to expedite our iterative procedure. For example, when we calculate this direction cosines, probably you have noticed we introduce a negative sign sometimes. And in fact, some of the books, if you go through, they also recommend that if you do this way, it is seen that your optimization will be faster. Those techniques are primarily for getting quick solutions. So that has nothing to do with the modeling. The modeling remains same. It all depends how you solve your numerical technique. For example, when you construct an equation of beta, and then you solve that quadratic or cubic, whatever may be the equation, to solve the next beta, that solution itself can be done in different ways. If you go through Ranganathan's book, then you'll see the way they solved, it's slightly different, because when that book was written, they used to solve everything in using calculator. So that's the reason they introduced one set of approximated solution in their algorithm. However, because we use MATLAB these days, we have a very straightforward solution. In fact, MATLAB itself has a toolbox. I have also shown you probably that in the course, or otherwise I will share that material. So you can directly use the optimization toolbox and just solve the problem in MATLAB itself. So my suggestion to all of you, just go through the mathematical model. So long your mathematical model is correct, you start with the initial value and then follow your calculations. Then whatever value will come, that we have to go through, and then we can comment whether it is correct or not, whether you have done any mistake in the procedure itself or not. Otherwise, if you have a difference in values, don't worry. If you complete the optimization process, ultimately you will get the same result. Any other question? Any more questions, anybody? In the next module, actually, we are going to discuss meta-model based reliability analysis. There you'll see a completely different model for reliability based design. We'll learn response surface methods and different versions of response surface method. That will be there in the next module, next 2 weeks, and then it will be followed by how we get different factors in the equations that we see within our code. So we'll have a code calibration. And then finally, in the last module, we will discuss the different topics that will cover again. We'll revisit form, and then we'll go through some other important reliability tools, for example, subset simulations, and then design optimization. And finally, we'll discuss stochastic finite element. So that will be really interesting for those who wish to take it further. So with that, we will close our course. So if you have any question, please ask me, or otherwise then we can end our session here. So let us wait for 1 or 2 minutes. If you have any question, please let me know. Yes, I believe there will be another live session. If our NPTEL team, they allows us, definitely we will come back. But we will always encourage all the participants. You please drop emails, and then whatever difficulties you have, whatever doubts you have, you please raise. Not only doubts, as I said at the beginning, that you please also mention how we can make this course more useful to you. So that's the main objective of this course. So we welcome all the suggestions, not only doubts. So we have email IDs with you so that you can use to raise your doubts. We have our team here, and including myself, anytime any one of you can reach us. We'll be more than happy to clear your doubts. And definitely I expect another live session, because we have a few other topics also, and some of the interesting topics that will come in the last module. And after that, definitely we will try to arrange one more live session in this course. Anything else? Any more questions, comments? By the way, I believe you can also come live. So I will request Cecile, if you can open your camera, just introduce yourself, and then that will be really great. So are you there, Cecile?
Yes, sir. Am I audible, sir?
Yes, yes. Can you just have your photograph in this team? I request our NPTEL team to have it.
So good afternoon, sir.
Good afternoon. Yeah, please introduce yourself and just let us know how, why did you select this course, and how you have gone through this course, and what is your aim in the long run, and how we can improve this course so that we can reach you, students like you, more.
Yes. Okay, sir. I am Shishir Bhatrai, sir. Shishir Bhatrai. My name is Shishir Bhatrai, sir. I am actually international student from Nepal, sir.
Oh, great.
And I have completed, sir, Bachelor's of Civil Engineering, and recently completed Master's in Earthquake Engineering from Kathmandu Tribhuvan University. And I have gone through, as I had mentioned in chat box, I have gone through your web-based structural reliability course earlier, and I was very grateful that when I came to understand there will be video version of the course, and I am really interested in the probabilistic structural dynamics, so to say. And I have also gone through, there are in NPTEL there is another also course, I believe, stochastic structural dynamics from CS Manohar, sir. I have also gone through, yes, sir. I have also gone through that, sir. So basically, I am very enthusiastic about this topic, sir.
Incidentally, I mean, it's great to even disclose that I learned reliability from Professor CS Manohar.
Yes, sir. I have. Yes, sir. You have masters. You have done masters there. I have.
Yes.
Gone through your CV, sir.
So, any suggestion how we can improve it further?
No, sir. It is good. I'm finding quite interesting, sir, this topic.
That's good. Thank you very much, Shishir. Thank you.
And also, I think you have planned another in another semester you have planned structural vibration, sir. I have gone.
Yes, that is about
Yes.
to come next semester.
Yes, sir. What will you cover, sir? If you don't, you
The details are there. I mean, I believe it is already there. So otherwise, you can drop a mail. I'll share. But for today,
okay,
let us fully focus on this course.
Okay, sir.
Yeah. So anybody else? Muhammad, are you there? I believe he's not. So yeah, Mohammed or anybody else, do you have any questions, or otherwise we can close this session here? Well, if not, let us close the session. Thank you very much, all of you, for coming to this live session, and particularly Shishir for raising so many questions and hopefully we'll have another live session. And also we welcome all the suggestions that you have to improve this course further. So with that, let me close this session here. Once more, thank you all. Thank you very much for the time being. Goodbye, but we'll meet again in the next module. Thank you.